green, what do you think if I say green? No context, green. Okay, green is the color of Spring Framework, the main color of the Spring AI conference. What is green? Unit test. That's a good one. It's so good when we see a unit test turning green, right? Also, yeah, all good answers, right? And is it even a question? If I say green, is that a question? You might start singing Defying Gravity from Wicked. Yeah, that's still a good answer if we say that's a question. When we interact with large language models, we have a big problem. Models are trained on a certain data set, so they can only generate answers based on the data set. And on top of that, models lack context. If I pick a book right now, open a book, and start reading from it, maybe you can see the title of the book. If I start reading out loud, you know what book the page I'm reading comes from. But if I ask a question to the model doesn't know. The model needs to know all the contextual information that usually we take for granted when we talk with each other or when we work in our daily life. So today I want to talk about how we can solve this problem with large language models. We're going to talk about how to bring context into large language model, in particular into applications where we want to integrate large language models with both our own data, with external data that the model is not aware of, and even with our own APIs. I'm Thomas Vitale. I work at Semantic as a software engineer. I'm really passionate about anything Java and Cloud Native related. I'm really happy today since Java is turning 30, so yay. I wrote a book about these subjects a couple of years ago called Cloud Native Spring in Action, and right now I'm working on a new book. It's called Developer Experience on Kubernetes, together with my friend Mauricio. It's now available in early access, and we are really having fun writing about how to improve the developer experience when working with cloud native applications. All right, but today will be a very practical session. So I built an application. It's a standard Spring Boot application. I'm using Spring AI in order to integrate with large language models. I'm using Vaadin to have a full stack application. So we're gonna have a nice UI all written in Java. And on top of that, I added a library of my own called Arconia, and in a minute, I'll explain what it does. So first of all, I'm integrating my application with a database. I'm using PostgreSQL. Then I really want an observability platform in place. I really believe that observability doesn't belong just in production. It belongs already at development time. And that's true in general, but even more important when we work with large language models, because there's so many things that happen under the hood. So we need to have that kind of extra visibility into what is going on whenever we interact with a large language model. And in this case, I'm using a Grafana observability platform based on the OpenTelemetry standard. Finally, of course, I mentioned I want to integrate with the model. I'm using a local inference service based on Ollama, but you can use a Cloud One, for example, Mistral AI. Something I like about Mistral is that they publish their models as open source. They're Apache 2 licensed, so I can actually run the same models locally with Ollama and then use the cloud service in production for high performance applications. And that's really cool because then I have the same model across the entire software development lifecycle. All right. I mentioned Arconia, so on top of a standard Spring Boot application, what I did was using this library I made in order to simplify the way we introduce observability into our application. So there is a starter dependency there, Arconia OpenTelemetry Spring Boot starter, which builds on top of the Spring Boot micrometer observability stack plus OpenTelemetry. And then I define 3 dev services. I mentioned that I'm depending on 3 external services, a database, an observability platform, and Ollama as the inference service. So with these 3 dependencies, whenever I start my application, I can use Gradle or Maven in the standard way in Spring Boot, I get all these services up and running based on test containers. So I don't have to define any extra code, no extra configuration, and I can still run my application as I would normally do. Or I also made a nice CLI that I can use across different projects, doesn't matter if it's Gradle or Maven. All right. I have my project open. It's running. We can have a look at the UI. I mentioned I'm using Vaadin. So if you saw the presentation I did yesterday with Marcus, you know a bit about Vaadin. If you didn't, there's a booth downstairs, so you can go and ask questions. But here I have a chatbot. Now, chatbots are really common nowadays. Like every company that wants to start working with AI, one of the first thoughts is, why don't we add a chatbot on our software, in our platform, or on our website? And I just want to show you how legacy software companies adding an AI chatbot to their product look like. Most of the times, it's just, we want to get that AI label next to our company name, so let's make a chatbot. And most of the times, it's implemented wrong. We mentioned a few issues yesterday in our presentation with Marcus, like we need guardrails, we need to ensure it's safe and secure, but today that will not be our focus. So this is just a warning. If you want to build a chatbot, chatbots can be really useful. Make sure it's implemented correctly and not just as a way to get that AI stamp next to your company name. So let's start talking about Retrieval-Augmented Generation. How does it work? I have here a normal chatbot. Let's do like this so you can see from the back. And in my code, I'm using the chat client builder. You probably heard a lot about this in this couple of days. And I'm simply sending a prompt to the model with a question. So let's start asking a question. For example, Spring I/O 2025 conference, who's the speaker presenting about Modular RAG? Let's see what we get back. I don't have real-time data access. Okay, the model was not trained on recent data. It doesn't know about Spring I/O 2025, so it cannot answer this question. So let's start addressing this problem. Now, the information is available on the Spring I/O website, so there is a page about my talk. So maybe I can copy this entire text, and I go back in my chat, and I can say, consider the following context, and I paste that whole thing, and then I ask my question. Based on that information, tell me who speaks about Modular RAG. So now I'm providing, as part of the prompt, the information the model doesn't know about. And now it can tell me, okay, it's me. That was a silly question to ask. But now it knows about me that I'm talking about Modular RAG. Now, every time I want to ask a question about data the model doesn't have access to, of course, I don't want to go and copy and paste all these text myself. I'm very lazy, so I don't want to do that. This is what is called prompt stuffing. We are augmenting a prompt with the context ourselves. So whenever we ask a question, we combine the question with additional information for the model to answer the question. So especially if it's about recent events that the model is not trained on, then this is one way of solving the problem and getting the model to actually answer the question based on the correct information. Because in the best scenario, it happens what it just happened to me, that the model says, sorry, I don't have access to real data, real-time data, or worst case scenario, the model will just make stuff up and just improvise an answer. And that's very bad. So we want to introduce this different pattern that is called Retrieval-Augmented Generation. So how does it work? We remove the responsibility from the user to provide the context, so it's only the question that we ask. And then inside the application, we want to take care of augmenting that prompt with the context. So the first question we need to answer is, where are we getting that contextual information from? We need a data source of some sort. In this case, I went online. Maybe I go through a web search engine, search for Spring I/O 2025. I land on the Spring I/O website, and I get information about all the sessions at the conference this year. So I can probably integrate a search engine in order to avoid having users to provide that information from the outside. And then through an HTTP API, perhaps, I can perform that call, retrieve all this information, and then inside the application, in particular inside Spring AI, we can augment the prompt with all the additional context. So we don't have to do it ourselves manually. Let's see how we can implement this pattern. So we go back here. I have my chat client builder here. Now, the first thing I want to do is defining a retrieval augmentation advisor. Now, an advisor is like an interceptor. Before we call the model, we want to perform some logic. So I'm going to define a RAG advisor, and I'm going to use a retrieval augmentation advisor, like this. Now, the list I can do when defining a RAG flow, like this one, is defining the source, the data source from where we can retrieve all this information. We have a component called the document retriever. Document is this API that Spring AI uses in order to collect data that is relevant to answer questions from different sources. So it could be of any format. And in particular, since we are working with a search web engine, I have here a search engine document retriever. So let's build that. And then we can look how it works. So this one, we said, performs an HTTP call to a search engine. So I'm going to use a Spring-own REST client in order to perform that call. So let's provide a REST client builder like this. We can also specify additional information, for example, how many results I want to get back from the search engine. Let's say 10. OK. Now that I have defined my advisor, I need to pass it to my chat client. So I'll define a default advisor. Perfect. Now, before trying this out, I want to show this search engine document retriever. This is based on an interface in Spring AI called document retriever. A document retriever based on a query, it returns a list of documents. Now, that list of documents, that contextual information, can be obtained from different sources. In this case, we want to fetch it from a search engine. So I have implemented this interface in this class. I have a search engine document retriever. I'm using a search engine called Vitale, if that's the right pronunciation, I'm not sure. But I have generated an API key, so I can perform HTTP requests to this API and get back results from a search engine. So if we look here, I'm using the REST client. This is standard HTTP interactions like we do in Spring Framework. And then I'm performing a search request based on my query. Let's see if this helps with our use case. So I have still my application. So if I ask Spring I/O 2025 conference, who is the speaker presenting about modular RAG, let's see what happens. And almost there. All right. So after a bit of thinking, Thomas Vitale is the speaker presenting about modular RAG. OK, that's correct. But I want to show you that what's happening under the hood is what I just said. So that's why I mentioned observability is really important. Let's look under the hood and see what's happening. I have here Grafana. This is running locally. Whenever I start my application, I get a bunch of containers. I have this Grafana container up here with OpenTelemetry support. I have a PostgreSQL database with the PG vector extension. We'll see in a minute how that's used. In any case, I get this out of the box, and now I can perform some searches across the spans. So I have last 15 minutes. Let's check for all the spans in here. Or maybe we can also do it from here, I think. Last 5 minutes. It's easier to find it. So we have the trace right there. Let me zoom in. Yeah, I'll close that. OK. And zoom. So this is the trace about the post request that just happened under the hood. So a trace, you can think of it as the visualization of everything that is going on as part of the application processing a request. So I can see all the different steps that my application is performing, starting from the web server in Spring Boot that is receiving that post request with my original question. And then what happens under the hood, that first of all, I'm using the Spring AI chat client. So I get information about that. Then I'm going through the retrieval augmentation step. We can see here from the modular RAG package in Spring AI. And as part of that retrieval augmentation process, we are performing an HTTP post request to the Vitale API. So we are performing this search under the hood. We are retrieving all the search results. And then what Spring AI is doing under the hood is combining all those documents, all those results from the search engine into the prompt. So let's double check that. I'm using here a Qwen 2.5 model running locally in Ollama, and we can see information about the prompt. So in the prompt, I have something that says context information is below. I didn't write that. I just asked my question about the modular RAG session. But here, I can see all the information that have been retrieved from the search engine. So there's a list of lots of different information returned by the search engine. And if we scroll all the way down at the very end, there is the instruction to the model saying, given the context information and no prior knowledge, answer the query. So it's basically the exact same thing I did manually before, all happening automatically, interacting with the search engine. That's quite convenient. So that's one way of performing this retrieval-augmented generation. We have a search engine. We perform an HTTP API call as part of this document retriever step. Now, this is the very basic pattern for retrieval-augmented generation. We also call it a naive pattern. It's a sequential pattern where we perform a retrieval step, and then we augment the query with the retrieved documents, and finally, we generate an answer using a large language model. So, two main steps. We retrieve all the contextual information the model needs to answer the question, and then we let the model answer the question based on all that information. Now, search engines are great, but you probably have in your company, in your systems, lots of information you would like to feed the model in order to be able to ask questions about all the data that you own, that your company owns or your customers own. So we can tweak a bit this pattern, but first we need to transform a bit our data in order that we can actually start using them as part of a RAG pattern. So if I have my documents, they could be documents stored in an SQL database. You might have PDF files or spreadsheets or images even, PDF documents, whatever the format is, we go through three main steps. And they're always these same steps thanks to nice abstractions that Spring AI provides. First of all, we have a document reader step with this API where we can read data from different sources. Next, we want to transform the data. Now, once we get the raw data, maybe from a PDF document, there might be extra information we don't need, or maybe the document is simply too long, and just store it all at once might be too much. We want to optimize to be able to search in a better way data during the retrieval augmentation step. So in this case, we are splitting the document into three smaller documents, so they are easier to search. And finally, we have a step where we use a document writer API in order to write this data somewhere. Now, a common way of doing that is writing it into what we call a vector store. A vector store is a database where we can store information in a specific format, which is a vector format. So we're talking about a multi-dimensional numerical vector. So it's a bunch of floating point numbers that all together embed the meaning of the text. So that's what we call semantic search, because once we extract the meaning from all the text, we can search not based on keywords, that's our way of searching usually, but we can search based on the semantics. So let's see an example in order to clarify that. We have our usual pattern here. The augment with context step now will interact with the vector store, and we're going to perform a semantic search. Let's see how that works. In my example, I have the document retriever step. I'm going to get rid of the search engine document retriever and replace it with a vector store document retriever. So you can see the modularity here. We have all these components. You can swap implementation to adapt it to your use case. We don't need the REST client anymore. We're going to pass a vector store. A vector store is an API in Spring AI that abstracts different data stores. In my case, I'm using PostgreSQL, but you can use it with lots of different data stores. So let's pass it there. And oh, it's the wrong import probably. Vector store, yes, that's the wrong one. Import the one from Spring AI, yes. Okay, now we are getting information from the vector store, but I haven't populated my database yet. I mean, I have lots of data. In particular, I have two children's stories here. Let's have a look. One story is about Yorek and Pingu that takes place in the Arctic Circle, and another story is about Lucio and Balosso that takes place in Italy. Now, I want to be able to ask questions about these two stories, about the characters, their journey. What I need to do is defining what is called a data ingestion pipeline using the 3 APIs I just mentioned. So I have here my ingestion pipeline. What I'm doing is providing the 2 files using the value notation from Spring Framework, so standard way of getting documents from the class path. I'm using markdown files. You can use any kind of file, really. And then we can start the pipeline. Let's zoom like this, it's better. So I'm defining a list of documents. Again, document is just an API, an abstraction in Spring AI to contain both the information and the embedding. And the first thing, I read the document. Since they're markdown, I'm using a markdown document reader. If you're using a PDF document, there is a PDF document reader, there is a text document reader, there is a JSON document reader, there's also a Tika document reader. This is really nice because it supports lots of different formats, so you can use maybe a Word document or a PowerPoint or a spreadsheet, and it will extract all the information from that document for you. All right. I'm reading those documents. I'm also providing some metadata. I'm going to show why in a minute. Then I'm going to splitting them using this token text splitter. Again, these documents might be too big, so I'm shrinking them. Have smaller chunks so that it's easy to search for just the relevant chunk when we do the RAG flow. And finally, I'm storing them in a vector store. So reading the documents, transforming them if needed. In this case, I'm just splitting them into smaller chunks, and then I'm storing them into a vector store. Okay, we have everything we need now to try this out. I have the document retriever. We are using a vector store, so it's working exactly the same as before, but now I expect instead of calling the search engine, I'm calling a vector store. Let's verify that is happening. So I might ask a question like, what is Yorek's biggest dream? That's one of the characters in the stories. And let's see what happens. Okay, we can see that Yorek's biggest dream is to go on an adventure around the North Pole. That's actually correct. Good. What if I ask a different question? So for example, I'm Italian. I live in Denmark. So maybe I want to use this application in Danish. So what if I ask my question in Danish? Let me try that. I need to switch the language keyboard here so I can ask the same question, but in Danish this time. Let's see if I can spell it. Maybe. Nice. So we get the answer that Yorek's biggest dream is to go around the North Pole. Now, this question might be a little bit tricky because the way that document retrieval works is based on the capability of the model that we use. I'm using a certain embedding model. I can show you the configuration, a model running locally called nomic embed text, like this. Where is it? This one. Now this is a very convenient model. It's quite small, so it runs very well on a local computer or at the edge. The problem is this model doesn't know many languages. And when I say doesn't know, it means it's not trained on documents in many languages. So you might run into issues when you ask a question in a language that the model doesn't know. And what happens is there is no match when you perform the search, because those vectors are only meaningful compared to the capability of this model. So if I ask a question in a language that the model doesn't know about, I will get 0 results, meaning the model will not be able to answer my question. Zoom out. So let's try again, and I'm going to show you why I'm doing this. So I'll switch to this other tab. Okay, now I ask the question, and the model doesn't know the answer. The problem is that I'm retrieving 0 results in this case, because I'm not performing any specific support for Danish language. The Nomic embed text model doesn't support Danish. So what do? I need to do something with my RAG flow. I have here the one I just used, just with the document retriever step. So if I want to support different languages, I need to introduce some preliminary step where I can translate my question from Danish to English, because I know that my embedding model knows English. And I can do it via a query transformers. Now, a query transformer is a step that runs before the retrieval step. In particular, we can use the translation query transformer. This comes out of the box in Spring AI. So I can use it in order to make sure that the question is asked in a language that the model supports. So I have target language English, and then I'm going to use a chat client builder here. So what I'm doing is using a chat model in order to translate the question to English, because the chat model knows about Danish, but the embedding model doesn't. So I can compromise here. I can have a very performant embedding model, which is really small, so I can use it to perform this semantic search, retrieving all the relevant information from the vector store, but at the same time I can use a more powerful chat model to compensate for that lack of support for all the languages. And you just saw the results. Actually, I was in the other tab where I'm using a query transformer. What happens is that we call the chat model, we translate the question to English if it's not already in English, and then we perform the retrieval step. And that works. This is a common pattern that I'm showing. We are moving now from a naive sequential RAG to a more advanced RAG, where we start adding some additional blocks here. We are performing a pre-retrieval step before the retrieval. And the goal of this pre-retrieval step is making sure that we can optimize the question for the retrieval step. In this case, I had a problem with the language, so I have to translate it. But there might be other reasons, because my question might perform differently based on how I'm retrieving data. I showed you 2 examples here. I'm retrieving data either from a search engine or from a vector store. But the way I ask the question should be different based on these 2 systems. Because search engines, maybe it's better to use some main keywords instead of a full-length question. But when I call a vector store, I might have a different format for my question. So as part of the pre-retrieval step, I can add one more component called rewrite query transformer. So I can chain these different transformers here. And the goal of this rewrite query transformer is to make sure that my question is tailored for a web search engine from the previous example, or in this case, a vector store. And then I'm passing a chat client builder. So also this one is based on large language models. So now I can tailor the question, so it's not the user itself using the application that is responsible for making sure that the question is answered in the best possible way. We can actually help the user under the hood with crafted prompts in order to ensure that they get the best results. Now, all these components I'm mentioning here as part of this Retrieval Augmentation Advisor, they are all configurable in terms of prompts. If we look at this rewrite query transformer, for example, there is a default prompt that Spring AI uses under the hood, but you can completely replace this. So you can provide your own prompt template. It might be because you want a prompt in a different language, or maybe you just want to tweak the prompt because based on the model, it might lead to different results. So it's important to have this, this in mind, that all these default prompts that come out of the box in Spring AI, you have the power to override them. So here I can provide my own prompt template and adjust it and tailor it for my specific use case. All these default prompt templates work for many different use cases, but you might have a situation where you need to tweak it a bit. So it's a good idea to think about it. All right. Now, let me get rid of all that, and let's analyze a different problem. When I'm retrieving data, I might get back lots of data that is not really relevant. I don't know if you noticed earlier, I might have it still open here. When we used the search engine, there was a lot of information that was not really useful to answer my question. I think, yeah, there was a lot of data like not really useful about tickets for the conference, about other information that really is not useful to determine who is the speaker of a certain session. So instead of feeding the model all this huge pile of text, we can actually optimize it and reduce it. Maybe we can compress it just to include information that is relevant. And the way we do it is adding one extra step to our RAG flow. We call it the post-retrieval step, where we can perform some optimizations of all the documents we retrieved before we call the model. Now here it's a place to refine the search that just happened, but it's also a place to make sure that we are not exposing any sensitive data to the model. Now the optimal situation is we actually don't allow a retrieval step to get back data you don't want the model to know about, but it could be an extra safety measure in order to make sure that all the documents we send to the model are approved. One example of that, I have it here. So we have a document post-processor step, and we have a compression document post-processor. So in the case of the search engine, for example, we saw there was lots and lots of data, and most of that was not useful. So I can use this compression post-processor in order to compress the information so that it only includes whatever is relevant based on my question. It works once again with the model. I can open it. This is something I implemented. So there is a prompt saying, hey, I have all this contextual information. This was the original question. Please make sure that only includes what is relevant. Synthesize a compressed version of it, because I want to reduce the noise and redundancy. And that's a common problem with Retrieval-Augmented Generation. There might be too much noise and redundancy in the documents that might mislead the model when answering the question. One of these problems is what is called lost in the middle. So you might have a really long text and the relevant information might be in the middle, and some smaller models don't really cope well with the relevant information being in the middle because they give higher priority to the information in the top and at the bottom. So this is one way of solving that problem. So extracting just what is necessary for answering the question. All right. This is the main way of doing RAG. Like we have these two ways. We have the naive sequential RAG and an advanced sequential RAG. And again, it's sequential, it's linear, it's really easy to follow. But now we can start making it a bit more complicated in order to support additional use cases. For example, we can start introducing branches. Now, this question I'm asking here, we saw a way to improve it by rewriting it. But there might be different ways to rewrite the query. Maybe there are multiple ways to phrase a question, and each of them could lead to different results. So instead of asking just one question and retrieving information about that question, we might actually expand the retrieval step so we can generate multiple similar questions, and for each of them retrieve documents. So here the goal is to maximize the chances that we are getting relevant information from a vector store or another data source. And if we do that, at some point we have to synthesize all that information, so we have to join all the documents fetched across different retrieval steps. Spring AI also has support for this. So using the Retrieval Augmentation Advisor, I remove this for convenience, but we can add, it's called a query expander. So we have an expander that takes a query and then it generates multiple variants, multiple versions of the same question, and then in parallel we'll call the retrieval step for each of them. So we have a multi-query expander like this. So we specify a chat client, we specify the number of queries we want to generate, maybe 3, We can also specify if we want to include the original question here or not. By default, it's included. And now if we do this, we maximize the chances to get a relevant answer. So let's give it a try. We already got good answers so far, but it was simple cases. But let's see. So who do Lucio and Balosso meet on their journey? Let's see. OK. So Balosso meets a brown bear named Balosso. So that really didn't help. Now I want to show something. Now here we expanded. Oh, no, I was on the wrong page. That's why. OK, let's do it. OK. Same answer. At least it's consistent, weirdly enough. But what I really want to show is what's happening under the hood. So let's have a look at the traces in Grafana. Now, by default, this is happening in an imperative way. If you're using reactive and you want to stream all these requests, you can actually do that. And the Retrieval Augmentation Advisor lets you customize the reactor scheduler. So if you want to customize the way that reactor schedules all these concurrent tasks, you can provide your own. By default, we are using a bounded elastic scheduler here. But you have the option to customize it. If you're not using the streaming reactive capabilities, this is not needed. All right, we have the trace here. Last 5 minutes. OK, that's the Modular RAG, HTTP, no, Spring AI chat client. OK, let's see if it appears. This one, 405, yeah, it should be this one. Yes, so here we can see the prompt. We are saying, you are an expert at information retrieval. Your task is to generate 3 different versions of the given query. So we are using a chat language model to provide 3 different variances of the original question that was, who do Lucio and Balosso meet on their journey? And then we go through the retrieval step for each of them. All right. Now, a more interesting example is what is called a conditional RAG. Because we might have different data sources we want to fetch information from. You might want to combine it with a search engine. And sometimes you just want the LLM to answer based on its own information on the same data that was used during the training of the model. So we can introduce a component that performs some routing. So given a question, we might introduce this component that performs a routing logic and routing the query to different places. So we might retrieve it from my vector store for one of the story, or a vector store from the other story, or might even be a different type of retrieval. It might be a web search engine. Now, I can do this as a workflow, so I can build on top of what I have in the advisor, but I want to show an alternative way of doing it that leads us to a more agentic behavior. Like in this case, we have a pre-made branches or for each of these routes. What I want to do instead is I want to let the chat model decide how to route a query. So this was the basic Retrieval-Augmented Generation that we have so far. What I need now, in order to have that dynamic choice about how and when to retrieve information, I need to introduce tools. So when I perform tool calling, I'm letting the inference service, in our case Ollama, know that there are certain APIs in my application that the model can call. Now, if the model decides that wants to call one of them, Spring AI will take care of executing that API. It's usually a method call. It will return the result to the inference service, and then the model will know all the context necessary to answer the question. So it's still a similar approach. We are providing additional context to the model, but we are not providing it to begin with. So it's not at the beginning. We are letting the model decide if and when to retrieve certain information by calling certain tools. And in our case, tools are typically methods in Java. So if we do that, we can obtain this more agentic RAG flow where we have this orchestration going on thanks to the tool calling. So we have the first retrieval we did earlier. We can call it tool 1 very creatively. We have a tool number 2. So we have a search engine retrieval and a vector store retrieval. We define them as tools. And then we let an agent, so basically we let a chat model decides how to route the query. So should it be using tool 1 to get the response, or maybe tool number 2, or maybe neither of them. Maybe just want to use a large language model to answer the question. And this is typically what we need because we don't work only with a certain single data store. So let's see how we can implement that. I can reuse all these components we have been working on so far, and the only thing I need to do now is annotating each of them with the tool annotation, like this. So I have this tool annotation with the description about the information I can retrieve from it. In this case, I have retrieve information about stories taking place in the world of Yorek and Pingu, and you can see the implementation. I'm using a chat client with the RAG advisor. So the exact same thing I've done so far. But now it's wrapped in a tool, meaning that now a model has the capability to use this only if necessary. And I've done the same for the other story. So this is where those metadata I added at the beginning come handy. So I have this filter expression that is provided by Spring AI, so I can filter results from a vector store. So I have one retrieval tool for the first story and one retrieval tool for the second story. And then I can do the same for the search engine. So this tool is for retrieving information by searching the web. Now that I have all these tools, I need to do something here. So let me remove the RAG advisor. So this now will become our agent. And our agent will need tools. So I'm gonna inject my tools class. So the tool class is just a Spring Bean. So you can see it's annotated with components, so I can auto-wire it in my agent, which is yet another chat client. And instead of specifying a default advisor, I'm gonna specify default tools. I pass that class, and now this chat client knows about those tools, meaning the model will know that it's a possibility to call those tools in order to answer a question. Let's see. So it's reloading. All right. Let me zoom in a bit. Is it done reloading? Yes. Okay. So I asked the question, what is Yorek's biggest dream? I'm still with the Danish keyword. Let's change it. Okay, now I can see Yorek's biggest dream was to go on an adventure around the North Pole. Okay, that's correct. So apparently it's using the right tool. Let me ask another question. Spring I/O 2025 conference. Who's the speaker presenting about modular RAG? Now it's taking a little bit longer because hopefully it's calling the search engine. Let's see. All right, and now it's answering correctly. So now I have one single entry point. It's what we call an agent. In Spring AI, it's still a chat client, but that chat client now is configured with several tools. Each tool lets the model retrieve information on demand, only if and when needed. That's cool. We can take this a step further. I've been using this web search engine. I implemented it myself. It was really easy to make this HTTP call, just using REST client. But because MCP is the latest hyped in this field, I can actually use the MCP server provided by Tabili. So using Spring AI MCP client, I can provide the Tabili search MCP server directly in my application. So instead of using a document retriever, I can use MCP in order to fetch information. And now what I want to show about this is the result will hopefully be the same. I'll switch to the other implementation where I'm removing my search engine tool, replacing it with MCP. Let me show you. I have added one tool callback provider, sync MCP tool callback provider, that is auto-configured by Spring AI, and it will include the documentation to call the tool via MCP. And let's see if it worked. Okay, it worked. It even added a link. Oh, that's very convenient. Thank you. So I know what I talked about. All right. Final thing. We've been working now with everything that is part of Spring AI 1 version GA, but there's some cool new stuff that you might have heard during the Spring Data talk earlier today, because Spring Data is now getting first-class support for vector data, meaning that instead of using the vector store abstraction in Spring AI, we might actually start using, when we perform this search as part of RAG, Spring Data repositories themselves. So this is very early preview of the feature. So I've been trying to implement a Spring Data document retriever. So it's still a document retriever in Spring AI, but the way that it works is it's not using the vector store API, but I want to use a standard Spring Data repository. And this is convenient because vectors is just yet another data type. So I don't want a completely separate database to store that data. I want everything in one place. So I have implemented these 2 steps. I'm using an embedding model to generate embeddings out of my question or my documents. And then I'm performing this search from the repository. So let's have a look, because that's the most interesting part. This is a JPA repository. And 2 new things, actually 3, that have been introduced in the latest Spring Data version, and more. Actually, this one will be part of the next major release. So in November, will be part of the Spring Framework 7 and Spring Boot 4 release train, where we have a vector API that we can use to search for embeddings. We have a score API. That is how we can tell the search mechanism how to find the relevant data. All these vectors are in a multidimensional space. The closer they are to each other, the closer they are in meaning. So the score is a representation of how relevant the data is based on my initial question. And then I'm using the normal way of building a query here. I'm searching for top 3, so only the top 3 relevant data by embedding near. So all the embeddings that are close to the input vector. And then I'm getting back search results. This is also a new API in Spring Data that I can use to extract all the information and map it to the Spring AI document API, which is what I did here. So I'm going from search results to a document containing the text and the score, and everything else works the same. So I'm really excited about this stuff, because it will make it very easy to integrate all these capabilities in your current data persistence layer in your applications. All right, that was my last point. Thank you very much for joining. I want to mention 2 things very quickly. One is we have a Spring AI community. So there's an organization on GitHub. You probably heard yesterday during the keynote, so check it out. If you have some ideas, some new features for Spring AI, that's a great place to incubate the idea and try it out and let people also share feedback. And one last thing is we just got Spring AI GA version. If you've been following the last few releases, you might have noticed that I made a way to automate the upgrades to Spring AI using an Open Rewrite recipe. So Open Rewrite is an open source framework to automate migrations in software. I made a recipe to automate Spring AI upgrades. So if you're not yet on Spring AI GA, you can do, I can show it here, you can use the Gradle or Maven plugin for Open Rewrite. You can find it on the Spring.io blog in the post about the Spring AI release, and also using my CLI, you can just say Arconia update Spring AI, and it will update your application to the latest Spring AI. Now, it's experimental still, but it includes lots of big changes that it's nice to get automatically applied to your project. Spring AI moves very fast, so it's very nice and convenient to have a way to keep up with the latest changes. All right. Thank you very much for joining. If you have any questions, I'll be around, and have a great rest of the day.